Please introduce yourself and briefly summarize your education and professional background.
Thanks, Todd. Thanks for having me today. My name is Greg Laugeni. I am the GCP manager for North America for Sterling Lloyd. I'm a NACE Level 3 certified certing coding inspector, and I have uh, extensive experience as a quality assurance, quality control manager with almost 4 decades of experience in the architectural, bridge, civil, and marine industries. And I hold numerous certifications from the Association of Materials Protection and SSPC, Steel Structures Painting Council.
Okay, so can you tell me a little bit more about what GCP does and what's their relation to the infrastructure industry?
Great. GCP is a manufacturer of specialized construction products globally and especially here in North America. Back in May of 2017, the company acquired us, Sterling Lloyd. We have over a 50-year track record in producing high-performance waterproofing and protection products. SafeTrack MTI was developed specifically for micro-trenching reinstatement during fiber optic installations, which is what we're talking about today. And I'm proud to be the GCP technical manager for North America for the Sterling Lloyd product lines and for the infrastructure division. What sets us apart is our world-class technical support, which helps build trust and stands out with owners, specifiers, and applicators, and all the other stakeholders, including telecom providers. And ultimately, we are from bridges to tunnels and everything in between. We protect the infrastructure that connects both the people and the world.
Okay, so let's talk a little bit more about these micro trench infill systems. So what are they and what role can they play in infrastructure projects?
Well, our SafeTrack MTI is a high performance cold liquid applied product, which is self compacting to help reinstate the flexible roadway system based on our unique SLAC resin technology. It's designed many years ago in Europe to infill roadways after microtrenching was performed for the deployment of underground fiber optic cables in microducts. What it actually does is it seals the trench of the top of the microtrench to protect it from water ingress and to support the sides of the trench to prevent the collapse of the roadway under the vehicular weight, and it contributes to the protection of the buried cable and provides a trafficable surface for the vehicles. The other advantage is that it cures quickly, and it has proven performance in colder climates, and it helps to minimize the disruption to the traveling public, which obviously reduces the economic impact to the roadworks. And this is critical in infrastructure projects to help keep it on time, ahead of schedule, and on budget.
All right, so a little bit about this micro trench. How is it different than I guess, regular trench, and how are they built before even the infill process takes place?
So a regular trench is normally 18 to 24 inches wide, and the depths can vary. A micro trench is normally 1.5 to 2 inches a slot cut in the roadway, and goes down 12 to 16 inches into the subbase. So it's a much faster and rapid deployment and return to service. And some of the biggest advantages of our product is it alleviates the project timeline challenges, and it's better than other alternatives. In long term, our resins are not moisture sensitive. They have no critical overcoat windows, which will dramatically reduce the need for ongoing maintenance compared to other products like cementitious grout or hot rubberized crack infillers. The result obviously is a lower life cycle costs to the end owner. And another thing to note is that when the SafeTrack MTI is applied cold, because it's cold applied, it eliminates the added costs of permitting and safety concerns of working with open flames when you're using hot products, which can potentially damage fiber optic microducts and or the network cables that you're protecting.
Are non-micro trenches also built into the existing roadway? I kind of picture them more along the sides of the road. Is that a distinction as well between micro trenches and trenches?
Micro trenches. You're talking about utility cuts, and utility cuts are normal trenches. The micro trenches are used often in on the sides of the roads. They sometimes can be in the roads to a certain distance into the roadway. Um, so it all depends on the deployment. This project on the Pennsylvania Turnpike is 325 miles. It would be a multiple year project if you were trying to do it the standard trenching way to deploy fiber optics or other types of utilities. If you were because of the amount of time it would take to open up the road, install and reinstate something of that size. So micro trenching definitely was the way to go uh, for the speed and for the this type of installation.
What were maybe some traditional or other ways to do micro trench infilling that maybe competitors use and why that you think yours is a better system?
Because of the fact that our competitors will use different types of products, you have to make sure that you're based on the site conditions of a given project. You want to use a material that's going to be most conducive and perform the best for long-term performance, but also be versatile enough to be able to be installed quickly and efficiently by the applicator during the process. Um, in different parts of the country, you see them using cementitious grout. Some people will try to use asphaltic material. Some will use hot bitumen crack fillers. Those have different type of applications. The Sterling Lloyd GCP SafeTrack MTI microtrench infill was designed specifically for the reinstatement of microtrenches with this high performance resin SLEC formulation that we have, which is the same formulation that we use for waterproofing of bridges and tunnels. So it is not moisture sensitive. It will not shrink or expand. It has great cohesive strength to the surrounding asphalt or concrete substrates. So the product itself is chemical resistant. It is resistant to gasoline, diesel fuels, and oils. Um, it will outlast and outperform the surrounding roadway. And so if there's going to be an issue, the cohesive strength of our product will far outsee the surrounding areas.
Okay, so we're talking today because I was made aware of a project called the Pennsylvania Turnpike Commission fiber optic network installation. Can you tell me a bit
Yep.
about this project and what it's trying to accomplish and who will benefit from its completion?
It's a 325-mile it actually consists of two contracts number 3 and number 4. It's a design build installation of a fiber optic network along the PA Turnpike from the Harrisburg East interchange to the Ohio border. So it's the western half of Pennsylvania. It's a 325-mile stretch, and they are installing a state-of-the-art fiber optic communications network to enhance the communication capabilities in that region. The new broadband network, it solves actually two issues. One is for the Turnpike Commission to increase connectivity to the administrative buildings and support the automated tolling. So that's where your taxpayer dollars will be going, as well as other advanced telecommunication applications for the improved safety, 911, and any future needs for obviously connected and automated vehicles. So if there are going to be automated cars or trucks traveling across the thoroughfare, they want to make sure that they have redundancy with small cell towers. Secondly, these rural areas surrounding the PA Turnpike are significantly underserved with broadband infrastructure. The new federal funding with the BEAD program, this will be in turn will get funding for it, and this will help reach these areas and extend fiber optic cable through the rural areas that have been overlooked for a long time.
So is the fiber optic, do they have like nodes in this installation that will branch out to the rural areas, or do these nodes, fiber optics, result in more cell towers that will be able to reach them? How do the rural areas getting the new broadband?
With the BEAD program, there's a combination of things that they'll be doing. So everything from you have your main trunk lines, which is what this is going down the highway. Then off of these trunk lines will be smaller cell towers and break off to other areas in different clusters. And then not only will the Pennsylvania Broadband Authority, which was developed to implement the BEAD funding, um, they will they are looking at everything from every option available for even some really remote areas. They'll be using some Starlink satellite access. They're going to make sure that they open it up to all the rural areas and to expand as much broadband they can to throughout that whole region.
Okay, and so since your product was used on this project, can you tell me a little bit about the process of how the bidding was, how you were selected? Can you tell me a little bit about how that worked?
So back in the fall of 22, during the bidding process for the projects, there were several microtrench infill systems that were evaluated. And after a demo that we conducted and having them do their due diligence on the SafeTrack MTI, our road reinstatement was selected both for contract number 3, which is with Coco Singh Construction Company, and contract number 4 with Swank Construction Company. Some of the main reasons why we were selected was the advantages of our product is that the seasonal weather in Pennsylvania can provide roadblocks for the microtrenching in the colder months. And since the MTI can be applied in a wide range of temperatures and our high performance proprietary resin is not moisture sensitive and will not expand or contract, this opened up the opportunity to the contractors to extend their construction season in both the spring and the fall, which would help accelerate the project, keep it on track, and even ahead of schedule. So most of the microtrenching operations are conducted during the overnight closures to limit traffic disruption to the public. Our product cures in less than 30 minutes in most conditions, and it forms a protective layer across the top of the microtrench, stronger than the asphalt's cohesive strength. And this lasting bond protects the underground infrastructure from freeze thaws and vehicle movement from the weight. Fortunately, it's in the shoulder, so there's a little less exposure to the weights of the traffic. And the other key element of why we were selected was because we have a SafeTrack MTI pump program, and our pump application and our rapid curing capabilities of this technology help to expedite the project and help reduce labor costs. So the pumps and equipment enabled the contractors to reinstate the microtrenches efficiently and productively, and are still being successful today.
Okay, I think that last part answered my next question. So you guys, in addition to supplying the product itself, you have your own trucks and applicators?
We don't do the application. We have our own pumps that we supply or rent to the applicators for the deployment of our product. So we manufacture the material, we supply it to them. We work with the contractors to assist. And as the technical manager, I will send the technical people out to assist in the deployment and the application of our products to the most efficient way, and to assist them in scheduling accordingly. And our pumps help them to deploy at a rapid pace. They, at one point, were doing almost 6,000 feet of reinstatement a night.
Okay, so do you know when this project will be completed, and is GCP still working on it now?
The Western Network installation is in the midst of construction. It's projected to be completed by sometime in early 2026, but they actually are ahead of schedule and might be able to complete most of the work by the fall of 25. Our tech service teams are still working with the contractors, both on the application, operations, and strategy to maximize their efficiency. And throughout the projects, our GCP team as a whole has worked closely with the on-site crews to provide technical support and product and pump operations.
Okay, so what would you say that maybe GCP learned from this particular project that that might make it better for future projects they can apply to other work?
Well, there were a lot of insights that we gained, valuable insights on these projects. One of the key takeaways was the importance of flexibility and adaptability in supplying and product application. The MTI system demonstrated its ability to perform well under varying weather conditions throughout the rural areas of Pennsylvania, in a roadway where they often had moisture or underlying sub-base materials that were never thought of. The project spans multiple seasons and climates, and this was crucial. This experience reinforced the need for a product that can be applied in a wide range of temperatures and is not moisture sensitive. And the contractors have said it time and time again. Additionally, the project highlighted the benefits of our rapid curing times and our efficient application processes. The fast pumping and application and curing capabilities help keep the project on or ahead of schedule at this point and reduce the labor costs, and then also ultimately also minimize the disruption to the traveling public. So without compromising on quality. And the collaboration with the contractors and the hands-on technical support that we provided was critical to this project's success, as the contractors have stated, and so has the Turnpike Authority. This experience underscored the values of our strong technical team, which I obviously will tout as the manager of the technical team. And moving forward, GCP will continue to prioritize these aspects to ensure that successful implementation of the product and will occur in future projects.
Okay, so to kind of bring this conversation back to our readers and viewers who are mostly they're going to be the civil engineers, some of them working on transportation systems, roads, designing new roads, maybe working on some existing roads and some adjustments like this one. What maybe should they be thinking about their job? I'm not talking specific products here. As far as, do you design roads now knowing that you're going to be wanting to put these kind of fiber optic systems in and you'll need micro trenches? Maybe some advice to think about as they're designing, thinking about micro trenches in general, and just some things they might need to think about when they're doing their designs.
Well, I think the one piece of advice I would give is the significance of selecting the right materials and technologies for the specific challenges of the project that they're working on. Depending on the location, temperatures, weather conditions, all those are factors. Return to service times, all the things that you need to prioritize in your design mode. The choice of MTI for its rapid curing time, flexibility, and durability has been instrumental in overcoming a lot of project timelines and weather-related challenges. Engineers should always consider these unique demands on their projects and choose solutions that offer the best performance under those conditions. Another important lesson is the value of thorough planning and preparation. The success of any project is due to the detailed planning and comprehensive demonstrations and technical support provided by a manufacturer and their technical teams. Because ultimately, it costs more to go out and do something twice. So if you can do it right the first time, it's better to get it done the first time. So engineers should invest time in planning and ensure that they have clear understanding of the project requirements and the potential obstacles which they're going to be facing. Obviously, collaboration and communication is also crucial. We coordinate with the contractors and the Turnpike Commission, and that was essential for a smooth execution of this project. And the engineers need to foster a strong relationship with all of the stakeholders and maintain open lines of communication throughout the project. Finally, the engineers should be adaptable and open to be learning and educated receive education for each project, because every project presents unique challenges, opportunities for growth. By learning and reflecting on your experiences and applying these lessons moving forward on your future projects. So if you don't learn from your mistakes in the past, you're never going to grow and improve in the future. Engineers can continuously improve their practices and contribute to the successful completion of future projects, which we hope that we'll be a part of.